to solve a problem about fluid mechanics, particularly in principles of hydrostatics. So we have here our problem. During an experiment, a big cylinder was filled with water and oil having a height of 0.15 meter and 0.07 meter respectively. If the container is open to the atmosphere with a determined pressure of 101.3 kilopascal, determine the gauge pressure at the oil and water interface. Also, what is the gauge pressure and absolute pressure at the bottom of the container? The density of the oil is 750 kg per cubic meter. So we have listed first here the given for this problem. The atmospheric pressure 101.3 kilopascal. The density of the oil 750 kg per cubic meter. And based from this figure, the height of the oil is 0.07 meter and the height of the water is 0.15 meter. So let's proceed to our solution. What we have to find first is the gauge pressure at the oil and water interface. So here, at the interface of the water and the oil. So for this particular pressure, we are going to find the pressure due to the weight of the oil alone. So pressure is equals to density times the gravitational acceleration and height. So substituting the values, since we all have the known values, we have our density 750 kg per cubic meter, the gravitational acceleration 9.81 meter per second square, and the height 0.07 meters. So we will get that our pressure from that is 515.025 Pascal, and dividing it by 1,000, we will get that it is 0.515 kilopascal. So now let's proceed with the gauge pressure and absolute pressure that we need to find at the bottom of the container. So for this pressure at the bottom of the container, we just need to add the pressure due to the oil and the pressure due to the water. So it is the addition or the sum of the pressure they exert. So the pressure for the weight of the oil is already known since we already have solved for it. We're just going to substitute the value of it, and now we are going to solve for the pressure due to the weight of the water. So the density for water is 1000 kg per cubic meter, and the gravitational acceleration 9.81 meter per second square, and its height 0.15 meter. So we will get that the pressure is equivalent to 1471.5 Pascal, and adding that, we will get that the gauge pressure at the bottom of the container is 1986.525 Pascal, and converting it into kilopascal, we will get that the gauge pressure is 1.987 kilopascal. So this is the gauge pressure at the bottom of the container, but the absolute pressure is, we have to add this with our atmospheric pressure. So the total pressure is the gauge pressure 1.987 kilopascal and the atmospheric pressure 101.3 kilopascal. So adding that, we will get that the total pressure or the absolute pressure at the bottom of the container is 103.287 kilopascal. So that's the solution for this problem.